Hello everyone, this is my first look at the Kinder Robot Kit and the Steam Cup suite or software suite. So the official name for the Kinder Kit is really Auto Kinder Kit, but I just shorten it to Kinder Kit. And the software block right now for our use consists mostly of R-Block and R-Motion. So R-Block is the replacing task if you are a user of ROBOTIC software a long time ago. Motion is a new Motion, not the old Motion 3 anymore. So I'm just going to go over the blocks software, selected some feature, and also some selected feature of the Motion tool. So the Kinder comes with the RB86 for its an integrated controller, or the brick usually people say. So it has 6 near-infrared sensor, 2 programmable LED, 2 dynamic connector. It X3P, so you can connect all kind of regular dynamic to it. It made specially just for DXL. I mean XL330, because the whole kit run on 5 volt. 2 motor inside, 1 on each side. It only one motor axle, independently controlled. It's using 2 rivet type. The big one 7mm in diameter, or the smaller 3.5mm in diameter. So this is the Dream system here, and this is the Play 700, Play 600 system. In robotics literature, they go by like this one they call 14mm rivet. It really mean the distance between the holes, and then this is a 7 the half size, so the hole is about 7mm too. So the Auto Kinder does come with a small manual, a thin manual. It has assembly manual there for 16 robots. But here you can see that after you use a 16 robot, you can build your own here, like I show you here. This is a boxer. This one integrates an XL330 here, so that it can clear object along the line. So this one can set up to track a line. You can add different kind of configuration. So this is more like a gear-like transfer of the motor axis from this point to this point. So you can put your another motor axle anywhere else on the frame if you need to. This one is also another application of the gear, but you're switching the rotation axis by 90 degrees, so you can get your own little battle bot here if you want to. So the big deal difference. So software, if you use with task motion, they plan to be self-executable cell application on Windows or Macintosh or on mobile devices. So this first one here, they let you access it through a website called enjoysteamcup.org. And this one here is where you get your software to create your program and test it out also. It is also where you can join circle, create circle, and posting your own work and other people here. So this is an international community, and also that's where you access your IDE. You can see R-Block and R-Motion here also, and then the virtual controller. And they also a mobile app for it, and it has for Android and iOS app, and also it's working on Chromebook. Kind of right now. There's still some little bit still things to fix, but maybe in the near future, that means by the end of mid 2024, the Chromebook version should work fine. So the Steam concept, essentially we have the R-Block and the R-Motion, the tool here. There's a controller, that's a virtual controller you can see here. This R-Block and R-Motion controller work with CM151. That's a new controller for the Dream 2 system. And then RB86 is for the Kinder system. RB88 is for the so-called Spark and XL system. RB100 is for specialized robot too, but we'll get to it. Now, although you can access from the web, at the present time, you don't have to be a member to register and log in if you want. Or you don't need to do registration and log in. Although it's free registration, you just access to it, and you can use the tools as an anonymous user. That's fine. There's certain things that don't have access to, like on some of the circle or some of the posts are private, so unless you are a member, you won't be able to see them, and then other things in here. But if you just want to have a place where you can access to program your Kinder robot, you can do as anonymous user. That's fine. So they have a lot of system now for these, as I call the so-called junior controllers, compared to their bigger brothers in the other systems. So first you have the CM151 for the Dream 2, and then you have an Allo system. The Allo system is a new Allo system. It has many kits. So Initiate, Kinder, Spark, XL, and Pro. Pro is not quite out yet, but probably maybe another year. So the Allo controller, you have RB86, RB88, and RB88 is made special so it combined, it can work together with RB100. So this is an interesting system here. It comes with the Spark, XL, and Pro. Kinder RB86 here. Initiate doesn't have any controller. And you also have single purpose, I call single purpose kits based on the RB100. So we have RG, Kodala, and TIG. TIG is a humanoid. So to access the RBlock ID online, this is the web page or web link where you go to. When you access to it, you have this. So in general, you have new savers, open block. You open a whole new different control here. I show you that a little bit later. And then you choose your own correct controller, like here if you are working on the RB88, and then you click on continue, and then it creates RB88 kind of special. When you choose on it, it creates 3 profiles. So I haven't seen it yet, but maybe there's a way to use all 3 controllers in one project. That's what I'm assuming. So this is new stuff. I'm looking forward to dealing with this. For us, we just choose, for the Kinder system, you just choose only a single RB86. I'll show you some other slide coming up. And then you connect them through BT, that built-in BT in all these RB controller. Look them up, and then you start programming, downloading, and play. In general, that's the interface. But you can also install an RBlock for an offline version. That is possible also. But the software and instruction is at this post here. But this post is private. So you have to be join the Steam Cup membership in order to get access to this post and then download and install your software. So essentially turn your PC into some kind of Apache web server. And then there's a web page where you hook up locally into it to get RBlock going. Okay, and it's working fine. So this is a little bit more detail here. This one, this is the RB86, and I'm using the online RBlock here. So this is how it looks like. So like for example, when you click on the hamburger icon, this big pull down menu come down. So it's new is to create your new coding program, and then you can log in through BT to connect to your RB86, and then the menu up here expanded to full here, where you can download, play, and stop. Bluetooth when it's connected, it look like that, and then it's other logging facility too. The USB here, the RB86, RB88 do not have USB connection, but the RB100 you can connect it through USB, so it's there for it. But for the Kinder kit, we don't use any of it. But let's go back to here to the main menu. So save as an open block, pretty much interface with the web drive of the Steam Cup organization. So that means what? You can create software anywhere. You can save it onto the web server of the Steam Cup association if you want to. Block UI, AI monitor, RBlock UI is, I show you later in the video part. This is just like a tutorial for the user interface, which is kind of handy. AI monitor, register motion gesture. These two are pretty much only useful if you happen to be using that mobile app to program your system. But the RB86 doesn't have any of the AI function anyway, so you won't bother with this one yet. Remote control, we will be using it. In the last four here, export PNG, it means that once you create your block diagram for, block program for your RB86, you can export a picture of your whole program if you want to as a PNG file. Import means to pull up RBlock file, when the program that you have created from your local drive. Export means from the server or online or offline RBlock tool. You can export, that means you're saving your block diagram or block programming program down to the local drive. So these are the tools. So you can see it. Save saver is open. These pretty much tools that you interact with the web server storage of the SteamCup website. Import, export are more on your local drive. So you have two ways to save your work if you want to. You can save it out on the web server of the SteamCup organization, or you can save your own local drive. Or you can save it to, you can work and save it on your local drive, the web drive up here, and then when you go home or something, you can go up to that website and download to your local drive if you want to, using import and export, and vice versa. So it's very flexible. You have you can work out on the web and save out on the web, or you can work and save locally, essentially what it boils down to. Okay, let's go into the detail more on what's going on here on the left hand side of the RBlock. So you have several grouping here: control, calculation, variable, function, sensing, motion, screen, sound, and line. So let's go one by one here. So in the control group, you see the usual forever loop, main loop, repeat, wait, if else. Nice thing is they have repeat while and repeat until, and also wait while and wait until. So you everybody should be covered with your favorite loops are available to use. You have stop to break out of loops and stuff like that, so that's kind of nice. And program as usual. Also, of course, you have the so-called block labels, and jump to the block label. So you have that. So that should keep everybody happy. Calculation-wise, you have the logical operation, and equal, and or not is here. And then you have the numerical operation, the arithmetic operation, plus, minus, multiplication, divide, and remainder. Also, you can do that. And then you have some constant, numerical constant you can use either in a regular number, floating point, integer and floating point, or in degree, depending on your application. You have a true or false kind of variable here, or constant if you want to. You can get a random number, and then you have the remainder operation that you can use remainder if you do integer operation. As for the variable grouping, once you create a variable, you define 3 blocks for you. A definer is, which is basically an assignment or initialization for your favorite variable, and then you can increment the variable by a certain number. Positive or negative, it doesn't have to be just by 1. And then for function, when you create a function, you give it a name, boom, it creates this run function. This is where you create your actual function in here. And then when you use it in other places somewhere, you can call that function. And then return, of course, is used as a last step, or wherever appropriate for your function in here. Sensing, so you can see that you can sense hand clap. So it's usually it has the little microphone, so it can The RB86 can only play some music or only. It doesn't speak or anything. For that, you have to use the RB100, but that's another video, another time. So you can check with infrared sensor if it is an object in there or not, or if the value for something, or the actual value if you want to. So this is taking care of handling with the near infrared sensor. So remember that 6 of them with the RB86. And the clap, of course, you have here, and then also the final count, either the final or the runtime or real-time count. You can have it here, or reset it if you want to. And then of course these things here, the 3 remote control signal related blocks, of course they are related to that virtual, that RC1 300. It can be virtual, or if you have money you can buy the physical RC1 300 also. And then of course you always can program at the start of your program. You can program how many times you push on it, and it's going to go into a different function or different process in your program if you want to. So this is used a lot in the example program that Robotics provide with the RB86. They use that. They have 8 possible separate tasks that the example code can do. And then we have the motion. Motion here is expanded a lot. I show you one by one. If you were already working with tasks and stuff like that in the past, or even R+ block in the past, is when they only provide you with one way to control the motor. Is essentially programming each motor at very small speed. Usually the speed is declared as a number from 0 to 100. But for RB86 is something completely different. And the feature they provide is very important for teaching youngest youngest and beginning programmers. Okay, so first, so I call them motion control levels. So the RB86 support 3 motion control levels for just those the 2 motor that they integrated into the RB86. First, there's a group that begin with robo, go forward, robot, turn around, stop, robot. So essentially you can see the command related to robot only. Okay, nothing is not mentioned anything about the motor on the left, on the right at all. So this is, I call motion control level 1. And what it does is when you invoke this command, the robot will, for example, robot go forward. What it does is it will go forward for about a second and then it stops. Okay, so these are very important procedures. Not the same as if you've been doing with Dream 2 or the Play 700. This is very different. So they built in a lot of, shall we say, friendliness for the youngest and beginning robotics. And probably as your teacher, this is probably very important. You're probably gonna enjoy these things here. So this is motion control level 1. So basically, each simple command, it will do the job. It will go forward or backward for about 1 second and then it stop. So there's no robot running amok, out of control, running off the table, that sort of thing, if you are teaching little kids before. Okay. And then there is motion control level 2, where essentially it's a command to the robot overall too. But now it's only a single block. But in there you have choices between slow, default, and fast speed. And then you also have direction. You have just a basic one, forward, backward, left, and right. So that's motion control level 2. So you can see that you're the young one, start out here, and then you can show down here more defined, where they essentially can control the speed now, essentially, when they're using single block only. So this kind of feed them toward, using function with multiple input. If they, they go up to where they program in C or Python later in their life there. And then there's motion control level 3. And now you are controlling the left or the right motor directly. You tell it to turn clockwise or counterclockwise, and then that speed, slow, default, or fast only. Now, if you're already using tasks in the old days before, usually the speed you can input a number between 0 and 100%. Well, with the RB86, the Kinder kit, robotics believe that they don't want the student to know that deep in detail yet. So you only have speed, you have only slow, default, or fast. So if you are in the education area, you probably saw this, and if you remember, there's something we call the spiral approach in teaching, where essentially you teach the same thing, but every time you teach it, you go into more detail, more sophisticated control. So they finally implement this kind of approach, at least how we call it in the US, we call it spiral approach, but in other countries, people may use something different. That's all I know over in the US this way. So this is a spiral approach implemented. So this is very handy. Because previously, when you, like for example, if you're using Dream and you use it to teach the student programming, you only have what? Rotate clockwise and counterclockwise, which motor you're talking about, and you have speed that vary from 0 to 100. So it's very detailed right away. That means what? If you teach programmer and a younger student, this is a very sophisticated tool to use it. And then you have to program, reword how you teach them in that way, and make it a little bit harder on the teacher. But now the kid just say, "Oh, I just wanted to go forward or backward." You can see the kids can handle this kind of logic better, and then you drill down to more detail with this MCL2, and then you drill more MCL3. Actually, the MCL4 and 5 in the RB88, that means the Spark, the XL and the Pro system. So that's two more level that you're going to see if you get into those systems. And then this is new. Remember that the RB86 have 2 DXL connector. They're essentially for dynamics of control. So I won't get into it here, but there's a lot. Here, obviously, if you guys know more about technical savvy, you know that it's accessing the control table of the dynamics of itself here. This is a way to do it. And so there are plenty of commands that they use for dynamics of control. Unfortunately, in the Kindle set, they don't even touch this. They don't even have example showing how you to use this yet, even. Okay, but so that means if you buy a Kinder, there's plenty of expansion room and more sophistication as far as controlling motor you can do. Okay, and then we have screen. That's your usual output to screen or line break. It can only output numbers. For the RB86 and RB88, only outputting numbers. Oh, I take that back. Maybe RB88 can have some text. We'll see. Sound, we just have melody and musical notes. And then we have new one. This is new. Line. Essentially, it's very sophisticated tools that they built in the RB86 and the R-Block software now. So if you wanted your robot to use the NIR sensors, all 4 of them, the one aiming down, to follow the black line, you just issue that command at speed 1, 2, 3. It's basically slow, default, or fast, and it will do it. It will curve. It will follow the curve. When ending the line, you say, "Oh, I don't want you to stop doing the line following code. Just stop." And then there's some other thing on the crossroad or intersection shape. I will show you some example of the different type of intersection the robot can do. We'll get into that later. And then these are more advanced one. This is the AI monitor tool. It really only works if you're having a mobile device to do it, because it can check how many people are in the picture, where your nose, FI, that sort of thing. You see, I have my Bucky here. If you're from Georgia, you know what this character is all about. You can detect sound, you can translate microphone, you can do text to speech, speech to text. So, but that's more advanced, and it's only if you do with the mobile app. there's nothing here for the RB86 to do, but just something to look forward to. And here we go. So like for example, I speak to it in a camera and I say hello, it translates into, it detects that yeah, I did say hello. So that's the so-called AI monitor tools. And then you also have the motion tool you can access. The motion tool obviously for system of DynamicSO, and it's right now it's set up for the TIC. As you can see, it's a humanoid, so it will walk and stuff like that. There's some more, and you can see, so that's the interface now, much more graphical, much more easier for the kids to do. And these are the different frame here if you have been using motion before. So all graphical, the interface, slider and stuff like that, so much more easier than and in the task motion 3. So I mean, everything is moved to graphical essentially. And also that's a more advanced tool. They're actually a small mini DynamicSO manager built in the motion tool. So, and I show you that in my book later. And so, but you can have access to different DynamicSO. You can check it, talk on, talk off. You can move it around just to check it's working okay. It will give you a present position and all of that here, the basic stuff. This is just troubleshoot if you have a tech into the DynamicSO area. Like I said, in the Kinder kit, they don't give you anything for DynamicSO. You had to buy that on your own, but just something to look forward to. So there are fairly lots of sophisticated tools that are built into the new Steam Cup software suite, shall we say? Okay, so the external manager one, and there's another one that I haven't tried yet, but it's called the Dance Manager. So obviously you have multiple robots to connect together and have a robot dance, and of course all of that doing on Bluetooth 5. So they're very advanced tool that the Ollo Steam Cup system is going to showcase in the next few years here. So there are plenty of stuff behind it. They haven't made them public yet, so we don't know how to do it, but there are lots of stuff there. And then I recently published this book, Companion Guide to Robotics Kinder. So essentially go over using the manual that ROBOTIS OLLO provide, and then with extra stuff. Mainly to study and develop your own robot on the mechanical engineering aspect. Also, of course, it's a software, it's a primer for how to use RBlock. So it will be that book that's coming up. So now here, I'm just going to use a video primer, how to use just a basic primer, how to use the offline and an online version of RBlock, so you can see. So this is another video here, so I'm just going to let the video and do its job. Hello everyone, this is what the RBlock, the offline version, looks like. So we start with go to hamburger icon, new, and then we'll pick out our controller, which is the RB86. Continue. We're gonna open an empty program, and that's what we get. This is all the RBlock stuff that the RB86 can do. You see it is also called as Ollo Plus. This is the profile of the type of controller you're working on at this point in time. So under control, we have the usual stuff. What a few there. Okay. Calculation, that's what you have. Variable, to declare to create a variable. For example, create, and let's say speed. There we go. We have the speed, and then we go to function. Yeah, we can create a function. Just give it a name. Forward, and then we got them under the robot block. On the grouping, you have actually several inside. So sensing, So you see clapping, or you have an object in front of the which sensor you're talking about. It has 6 NIR sensor. Under more, you can see an air specific eye sensor. This is obviously something about the hand clapping using the built-in microphone on the RB86. And then all this here is about using the virtual remote controller RC300, and also how many times the button is pressed. Motion, so you can see that there's quite a bit. So all these things here relate to the motor on the RB86 itself. There are 2 of them. These are the LED on the RB86, and then you have another way. So this is one set of motion control level. I call motion control level 1, where you just do the command on the robot directly. You don't have to worry about anything else. And what it does, each time that you have, for example, like here, the robot go forward. But this group here, every time that you invoke one block, it just do that function for about 1 second, and then it stop. And then also another level, motion control level 2, you change it direction and speed. So you have slow, default, fast, and then you have forward, backward, turn left, turn right. Okay, so that's level 3, motion control level 2 I mean. And then you have motion control level 3 here, where you control, is it the left or the right motor, which speed you wanted that, and then which direction you're turning it, clockwise, counterclockwise. So this is the first time in sort of R-block software where you have 3 levels of control of the motor. So you can see that it will help you if you are teaching and the students are very young. You can just go with the robot, simple command, go forward, backward, and then you can tell them to control the speed and the direction, but using a single block. And then higher level, you go and control the motor directly if you need something specific to do. And then okay, and then screen, you can output to the screen, output the line break. It means it come out from this screen here. Please connect to the robot. So that's my try that. So this is the Bluetooth. My RB86 just went down, so it come up again. Now it's highlighted. I can pair. Okay, when it's pair, you see it changing. It's obviously to download the program. This is to play the code on the RB86. Let's continue on here. So the screen, we already done that. So the screen is, let's say you have this, and then it will appear here. So call it screen. Sound, of course, we have the various play melody and play the music tune. Line is new. Essentially, you can do it can follow a specific black line and the line following macro. You can check to see which kind of shape it is. For example, left, right, a U-turn. And then you also have this one, is very important. You can see that by default they already built in the macro in the firmware for you, so that you can detect different kind of cross sections, intersections to read rather. So that's how you create your code, block diagram, block programming. And then let's say we are ready. So of course this is just all nonsense here, so it doesn't do anything. So let's say you download, say no block connected. So are you sure you want to download? Click OK. It's still trying to download something anyway. It probably messed up the R86. It's put down 15 byte. Okay, so you probably just put down the press to start, and then if you have a decent code, and then you can of course push play. Hello everyone, so this is what the R block, but the one is online version looks like. So if you go here, you have new, and then we choose our own IT6, continue, empty program. Right here, right now I'm using the anonymous version. I didn't log in into my Steam Cup account at all, but you can use this software as anonymous user, no problem at all. And okay, so let's see. So it already picked up RB86. You can see that inside our block, it known that as Auto Plus. Let's have a look at here again. So these save as open block, that pretty much works to save or to download from the web drive of Steam Cup organizations. So I'm not logged in, so it didn't make sense to accept any of that. You have the RBlock UI. You can click on this. It shows you what different area, what it does. So kind of a tutorial. AI monitor, virtual motion. That's pretty much that for when you use the mobile app or your iPhone or that sort of thing. Remote control, it give you this virtual RC300 here. Export PNG, it basically capture a picture of your block diagram program and then save it as a PNG file. Import and export, these are important because what they do is they import from a file that you save on your local drive, and export is to export to your local drive from the online tools. Okay, so we have so let's get back. So the control looks like this. All these control blocks, it's quite a bit. Calculation, variable, same thing like before. So you create a variable. And on one, for example, create that one. Function, create a function. IR sensors, and then you create them. Okay, under sensing, so you have is obviously pertaining to hand claps. So we can monitor the different 6 near-infrared sensor here, and then these are for the sound clap, hand claps. And down here is more for the remote control, RC300, and then also how many times the start button was pushed when you first start on the program. Motion, there's quite a bit, quite a few. So these are for very much beginners. You just say robot go forward, and it turn on the 2 motors as needed to go forward or backward or left. And these commands, they last only for 1 second, and then the robot stop. So that's you can turn on the LED. You want to program that, and then that's the next level of control. You can tell the bot move which direction using a same block, but you can specify the direction. Slow, default, fast, or forward. Okay, so let's try that again. So you can have that. Also, of course, you can mix. Of course, you can have it MCL motion control level 2 here, and then you can just want to stop the robot. You can just do that. You can mix different motion control level block to use in your program. And then the last one, control level 3, where you specify left or the right motor, where you can go slow, 44, or fast, and you can rotate which way, clockwise or counterclockwise. Okay. If you have used ROBOTIS software before, you say, oh, I used to be able to find and control the motor as a value from 0 to 100. Yeah, that doesn't happen on the KINDER system. They only let you do that on the RB88, that means in the Spark or XL system. All these are for the XL port. The XL 330 you can add to the system if you want to control that. The KINDER kit doesn't have the XL 330, you have to buy on your own. But in my book I show you how to do some basic programming with the XL 330. Screen, output to screen, and it came from here. Okay, the robot just turned itself off, so I need to turn it back on again. The robot. So to connect to the robot, you click on the Bluetooth button. It finds it, we pair it. Now it's connected, and then the menu up here changed. So this is for download program your program to the RB86, and this is to play for it. Now this one here is just all nonsense here, so it doesn't really do anything, but you can try. You download something already, but probably nonsense, so we don't want to run that one. Screen, for example, you can do that, and then they come out from this screen here. The screen look like this, and then just numbers only, no text for the RB86. Unfortunately, no output of text. And then sound, of course, you have the usual play melody, wait, or you do the musical note. Line, this is new. So these are the functions you can use to help the robot use the NIR sensor and track a line. So you can just, it's a macro. So that means you just tell, oh, I want you to follow the line at speed number 1, number 2, or 3 at half speed. That's all you do. And the line can be very much irregular. So you can do for example, here, this kind of give you an idea of the different type of intersection it can track for or it can detect. So it's very sophisticated software, and so all this is built in. So this is like an example. If you export PNG, it saves you a screenshot, and it's saved onto my local drive. Import. See, I had some of them already made up. The extension block on mine, and then to export, you have to give it a name. Click OK, and then you can choose the folder where you're gonna put your program. Okay, that's it.